Welcome viewers. This is Mathman Academy. So we have on the screen today we have Bernoulli equation. It is an advanced engineering mathematics. Let us just say advanced mathematics. Not only engineers that uses this application. The mathematicians themselves they use it. Even physics it is utilized there. So now to start with a Bernoulli equation. When is Bernoulli equation is used, or when are you going to be sure that I'm going to apply Bernoulli principle here? The thing is that some nonlinear first order differential equations can be reduced to the linear form by change of dependent variable. What do we mean by dependent variable? Normally in our basic mathematics we know that from equation of a straight line, y is equals to mx plus c, where y is the dependent variable, then x is the independent variable. So that's just from there. This is the explanation of dependent variable and what independent variable. You understand? Now here we now want to see what is first order. What's it called? What do we call linear differential equation and non-linear differential equation? Let's quickly look at this one now. If you consider this equation, y is equals to y prime plus y is equals to sine x. This is a differential equation now. Is that taken? Now here, this one is known as what? The first derivative of what? Of y. And this is y itself, the dependent variable. And this is what? Sine x, where x is what? Independent variable. You understand? Now here, this one is regarded as a linear equation. How do I know that it is a linear equation? One of the conditions to know that an equation is what? A differential equation is said to be linear is that both the dependent variable and its derivative, is that taken? They are in first degree. What do we mean by degree? If you have a raised to power n, this thing is regarded as what? As power or degree. Is that taken? So here now, what we have at the top of what? That thing is known as what? Degree. Now here, this y has invisible 1. I can write it as y raised to power 1. Then even this one, I can write this one as what? Y raised to power y prime raised to power 1. Is that taken? So if an equation, is that taken, appears to have, the dependent variable and its derivative are in first degree, then the equation, that's what? One of the reason or condition that will show that what? The equation is what? Is linear. Another condition is that there is no product of the dependent variable and its derivative. What do you mean by derivative? Another derivative of what? Of y. The derivative of y are y prime, y prime prime, y prime prime, like that. Is that taken? This one is what? The y dx. Then this one is the square y, the s squared. Then this one is the cube y, the s cube, and like that. You understand? So here now, so we've known. Now I said that what? When there is no product of the dependent variable and its derivative, then the equation is said to be the equation is said to be linear. It's not complex enough. No.